The addition or subtraction of matrices is too simple. There are many things, we are going there later. Let's see how we add the matrix A and the matrix B. The matrix A is like this and the matrix B is like this. There are rows and columns involved. We don't need to understand that for adding or subtraction. So if we add it, what we do is we write A plus B and we write the matrix format. Now what we will be doing is look at the position, top left, top left. We just add the two terms and we are done. So what we do is take the 6 from there, take the 2 from there. The reason we have to add it, add it. Next location, left to right. So we pick up this value from there. Basically it's a row 1, column 2. We don't need to understand or know that for addition. So all we do is pick up the 3 from there, pick up the 8 from there and add 8. Next is bottom left over here. So we will do the same thing. We will pick up the 2 and pick up the 11 and write the addition over here. It's 2 plus 11. Next one, we pick the 9 and pick the 3 and add them and write it over here. Come left, it's a 7 added by the 1 because it's A plus B is 7 plus 1. Pick the 7 from there, pick the 1 from there. Choose the sign and add it. Pick up the negative 1, add the positive 16. And the result is just simplify the values. 6 plus 2, we put the 8 there. 3 plus 8, we put the 11 there. Remember, there is no plus and minus, it's a notation. We will discuss it later, not to worry. Now, 11 plus 2 is a 13 there. 9 plus 3 is a 12 over there. Just look at the location and the position. 7 plus 1 is 8 here. Negative 1 and the 16, which is a positive 15 or a 15 over here. It's very simple to add it and it's very simple to subtract it. If it was subtraction, we would have subtracted the same values from the same location. So it would have been 6 minus 2, 2 minus 11 and all this. Finally, there is something to watch. That was a formal way. We went from left to right, left to right, left to right, left to right. It's not just a formality, but basically what we did is just to watch it very simply. We picked up that column, write it, picked up that column, write it, add the two columns, done. Then what we can do is we can pick up this column and pick up that column. Write that column on the left matrices, write the column on the right matrices, add it because it's added, and the final value is on the whiteboard. Too simple. Another simple example, we have to multiply this, the name of the matrix is A and is written in this format. We have to find what is 4A. 4 means what is 4 times A. So we have a value, location and position wise is row 1, column 1, still row 1, column 2. We will decide that later. How can we multiply that by 4? It's too simple. Write 4 times A, that's the name. The value, remember, what we do is just write and pick up the value, location and position wise they are. This time we are skipping the systematic way left to right. Just write these values. 2 under this 2, down is 6, 5 on the top, 9 on the bottom. The reason we have to multiply it by 4, every single term will get multiplied with 4. We can do it stepwise or we can just write. And the simplification is we have to multiply 4 times 2, write it on the right position. We have to multiply 4 times 5, write it on the right location. 4 times 6, write it on the right location, which is 24. 4 times 9, write it on the right location. Easy. Now on next videos, we have to learn some systems. Now we have to understand some system and some laws of matrices. We always call a matrix by the row value first, the column value next. Example, suppose we have a matrices which is row 2. We're not doing any math on this part, that's why I'm not bringing any numbers. The horizontal is 2 rows, that's why it's R2, and the vertical is 1, 2, 3, 4, C4. So it's always the R times the C. The size of these matrices is, we write the row first, then the column. 2 by 4 matrices. Another example, if you have a horizontal row 2, vertical row 3, what is the name of the next matrices? It should be R times T. So it's 2 times 3. It's a 2 times 3, 2 by 3 matrix. Another example, because we are doing some multiplication with matrices versus matrices, the row and column is very important part. Previously we have done the addition and some simple multiplication. We didn't have to know anything. Now, third example, 1 horizontal, 2 horizontal, 3 horizontal. It's a row 3, and 1 vertical, 2 vertical. It's a 3 by 2 matrices. So now we know how the row comes. 1, 2, 3. That's the row. 1, 2, 2 vertical. That's the column. Now next example, we have a same row, same column matrices. It's a 3 times 3 or 3 by 3 matrices. And another one, we have a 2 by 2 matrices. So it's a 2 rows, 2 columns. And 2 by 2 matrices are also called square matrices. These are the few things we have to understand. And that's it for this lesson. We are going to the next video. Now, in this video, we have to understand how to name a precise number on a precise location. So this example we have is a 4, 1, 2, 3, 4. The row is 4 rows and the columns are 1, 2, 3. It's called a 4 by 3 matrices. But what if we are looking for, what about, we would like to say, what is the location of this number? Is over there, is over here, is on top of 7, is on, we don't speak like this. We have a notation for this one. So we just call it is B21. We are talking about the matrix B. The 21, B sub 21. The B stands for is say row 2, and the 1 stands for is a column 1. So row 2, column 1 is the location for this 4. This is how we point out a number in a precise matrix. Now what about another number which is B12, B sub 12. 1 is the row, 2 is the column. So this is row 1 and that is column 2. So we are definitely talking about that number of 2. So this is how we write B112 is row 1, column 2. We are talking about that number 2. And what about B sub 43? So 4 is top 1, 2, 3, 4. We are talking about row 4 and the column 3. So we are talking about this location. That's the number we are talking about. So B sub 43 means we are talking about this number 3. Now another example, if we have all zeros in a matrices, the row, column doesn't matter. It's a 2 by 3 matrices, row 2, column 3, but it's a 0 matrices. That means if we see a word where A is a 2 times 3 0 matrices, we just write every number 0 on the matrices. And there is another special matrices which is always named I. I is the identity matrices. And the matrices looks like this. It's called a 3 by 3 identity matrices. The reason for this number is row 1, column 1. That number is row 2, column 2. And that number is row 3, column 3. You can see the 11, 12. So it's a location is I sub 11, I sub 22, I sub 33. That's the reason it's called a identity matrices. We are having another example, subtraction of 2 matrices. The green has to be subtracted from the yellow. It's a very simple one like the addition we have done in the beginning. So we choose the location is row 1, column 1, row 1, column 1. So it should be 5 and 6 that has to be subtracted and written the value over here. We go from left to right. So it's going to be 9 minus 3 and we have to write the value over here. Then we come to the left down, which is row 2, column 1. We pick up 2 from same location, pick up the 3 and subtract 2 minus 3, write it over here. We pick the 0, pick the 5, write 0 minus 5 right over here. And finally, all we have to do is simplify, and all the simplification will take the same location and same position. So 5 minus 6 is a negative 1, 9 minus 3 is a positive 6, 2 minus 3 is a negative 1, 0 minus 5 is a negative 5. The addition subtraction is too simple. You can watch the video one more time, you will understand it is too simple. There are some complex situations, we are going step by step. Now another example, what if somebody calls, find the resultant of, we pick 3 examples. We did 2 matrices before. When we have 3 examples, 4 examples, 5 examples, doesn't matter. We just choose these 3 locations. The resultant will be the same 2 by 2 matrices. All we have to do is choose the location. So make the box, the 8, the 1, and the 5. Every value has to be we see the addition. So it's going to be the 8 plus the 1 plus the 5. And it's placed exactly on the same location. Then we choose the 3, the 7, and the 6. And we put these values side by side with all addition. 3 plus 7 plus 6 over here. And the plus 6. Next we choose the 11 plus the 2 plus the negative 3. Then the last location we choose the 9 plus the 6 plus the positive 8. So it's 9, the 6 from there, and the 8 from there, and we put positive in between because it has to be added. The resultant is going to be the 2 by 2. All we do is simplify the value. 8 plus 1, 9. 9 plus 5 is 14. Next is 3 plus 7 is 10. 10 plus 6 is 16. 11 plus 2 is 13. 13 minus 3 is 10. We write it here. 9 plus 6 is 15. 15 plus 3 is 5, and it's 23. We write it here. And we are done. Now we have an example. It's called find the resultant, or we can word simplify the matrices. We have yellow matrices, which is 5 times the value minus 4 times the value. We did it before. Basically, this 5 should be multiplied with 3. This 5 should be multiplied with 1. This 5 should be multiplied with the other 3, and the value we'll take is position. We can do a step by step. The yellow part will be simplified. The 5 will be gone. It will make every value 5 times bigger. We will take the position. And we will take the 4 over here. The green value will be 4 times the 5, 4 times the 1, 4 times the negative 5, 4 times the negative 2, and 4 times every single number. It will get simplified. The 4 and 5 will be out. And it will get a simplified value over here and a simplified value over there. Just to save time, what we can do is, we know we have to multiply every value. Nobody is understanding it. All our job is to get the right result. So copy the matrix and copy the matrix. So we copied all the number, multiplied it every term by 5. We know we have done it before. Next number, write all the value. I'm using parentheses just to show it nicely, and every number will get multiplied by the 4. And the simplified value has to be written simplification. With the simplification, so it's going to be 5 times the negative 3, 5 times the 6, 5 times the 1, and all numbers will take the same location and same position. So it's going to be 5 times negative 3, negative 15. It's going to be 5 times 1, the 5, 5 times 3, the 15, 5 times 6, 30, 5 times negative 2, negative 10, 5 times 4, 20. From there, we have got a simplified part, the last simplification of the yellow part. The green, 4 times 5 is 20, 4 times 1 is 4, 4 times negative 5 is negative 20, 4 times negative 2 is negative 8, 4 times negative 1 is negative 4, and 4 times 7 is 28. We could have done the second steps step by step, but we saved a lot of time. Copy and multiply every term. Now, when we have the simplified version of the yellow matrix and the green matrix, now it's time to subtract, and we have the experience. It's going to be the same. It's 2 row. Let's just show the row. It's going to be 2 rows and 3 columns. It's going to be the 2 by 3 matrices. But when it's addition and subtraction, we don't need to work like that way. What we just do is take the location, first position, 15 is a subtraction, so it's going to be 15, subtract 20. Go to the next location, it's going to be 5, subtract 4. The next is going to be 15 minus of minus 20. So it's 15. We just use the parentheses, minus of the minus 20. Next line, 30 minus of minus 8. So it's 30, subtract the minus 8. 10 negative, so negative 10, subtract the negative 4. So it's negative 10, subtract with the negative 4, 20 minus 28. Before we proceed to the next step, I would just like to point out, we have picked that column and picked that column, and we have just written it like this. We could have picked the entire column, subtract sign in between, and put the other column. And same thing we could have done, write that column, subtract, write the middle column, write the third column, subtract, write the other column. That's another fast track of doing it. Now all we do is simplify the values and write it on the next term, and that's the final answer. Negative 15, negative 20 is a negative 35. Row 1, column 1. Then we go to the, keep the same row, move to column 2. We will have 3 columns there. 5 minus 4, that's the middle column or column 2. The third column of the last column on the first row, 15 minus of minus 20. So it's 15 plus 20, which is a 35 positive. Then row 2, column 1, simplified version of the 30 minus of minus 8, basically is 30 plus 8, 38. Negative 10, negative of negative 4. Negative is positive 4, and the negative 10 with the positive 4 is a negative 6. 20 positive, 28 negative. 2 different sign is a subtraction. Keep the sign of the bigger number. Subtract the small number from the bigger one. So it's a negative 8. Done. Just a quick review. That value went there. This value went there. This simplification went there. That simplification, location and position went there. This simplification went there. And finally, the row 2 and the last column went there. And this is the way we do the simple addition and subtraction and multiplication in matrices by a simple number. That's the way